Dear students, we have studied pressure, temperature, volume, number of moles, heat, work, internal energy are the different thermodynamic properties or thermodynamic functions. In this lecture, we are going to study one more thermodynamic property or thermodynamic function, enthalpy. Along with enthalpy, you will see what is enthalpy change. What is the relation between enthalpy change and other thermodynamic properties? And if possible, we will solve one numerical problem. For your better understanding, students, and for my explanation also, let me allow to share the slides with you. Give me 2 minutes. Students, here on the slide, there is one question. What is enthalpy? Okay. Enthalpy is actually one of the thermodynamic properties. The symbol for enthalpy is H. It is also called heat content. Don't forget, enthalpy of system is also called heat content of the system. And if you want to write mathematical equation or you have to define enthalpy mathematically, then what equation you will write? H is equal to U plus PV. H is enthalpy. Here, U is internal energy of system, P is pressure of system, and V is volume of the system. What is the mathematical equation for the enthalpy? When you have to define enthalpy mathematically, H is equal to U plus PV. And suppose you want to write definition. It is asked to write what is enthalpy of system. Or your suppose question is define the term enthalpy of system. And for that, you have to write in words, enthalpy of the system is the sum, addition of internal energy of the system and energy equivalent to PV type of work. Once again, I'm repeating, enthalpy of the system is the sum or addition of internal energy of the system, that is U, and energy equivalent to pressure volume type of work. That is, in short, H is equal to U plus PV. Enthalpy is a state function. If suppose question is, why is enthalpy a state function? What will be your answer? Enthalpy is a state function because it depends on only initial and final states of the system. That's why enthalpy is a state function. See, absolute value of enthalpy cannot be calculated. Or in other words, total enthalpy of system cannot be measured. But change in enthalpy, enthalpy change can be calculated. Since enthalpy is a state function, how to calculate enthalpy change or change in enthalpy? Enthalpy change or change in enthalpy, that is delta H, is equal to H2 minus H1. What is H2? H2 is enthalpy of final state and H1 is enthalpy of initial state. Suppose our system is a chemical reaction. Then what is H2? H2 is the enthalpy of product state because product state is the final state. And when System is a chemical reaction. That time H1 is enthalpy of initial state or reactant state. When H2 is greater than H1, the sign for delta H is positive. Now, of course, when H2 is smaller than H1, that time sign for delta H is negative. We'll skip to the next slide. On the slide, you'll find there is one question. Show that enthalpy change of a system is equal to heat absorbed at constant pressure. Can you write this equation mathematically? That is in the term of equation? Yes, should. Enthalpy change means delta H. And what is the heat absorbed at constant pressure? QP. Symbol for heat is Q, and when pressure is constant, Q becomes QP. So QP is the heat at constant pressure. But here heat is absorbed. And when heat is absorbed, when heat goes to system, that time Q is positive. We have seen the sign convention. So QP is positive. Why? Because heat is absorbed, heat goes to the system. So in short, we have to show delta H is equal to QP. So sometimes question will be only show that delta H is equal to QP. So to understand, delta H means enthalpy change of a system, and which is equal to QP means heat absorbed at the constant pressure. Subscript P indicates pressure is constant. Subscript P written after the Q indicates pressure is constant. Now, how to write the answer? Now to start with delta H. How to calculate delta H? Delta H is equal to H2 minus H1. For the answer, we have to move for the next slide. It is a state function. Therefore, H depends only on initial and final state. Therefore, enthalpy change, that is delta H is equal to H2 minus H1. Now, using the mathematical equation of enthalpy H, we can write the value of H1 and H2 at the initial state and final state. Since H is equal to U plus PV, H1 is equal to U1 plus P1 V1, where H1 is the enthalpy of initial state, U1 is the internal energy of system at the initial state, P1 pressure, and V1 volume of the system at the initial state. Similarly, we can find the value of H2. So H2 will be U2 plus P2 V2. H2 is the enthalpy of system at the final state. U2 internal energy of system at the final state. P2 and V2 are the pressure and volume of the system at the final states. So in short, by using the mathematical equation H is equal to U plus PV, you can find the values of H1 and H2. So H1 is equal to U1 plus P1 V1, and H2 is equal to U2 plus P2 V2. We have to put these values in the equation of delta H. Since delta H is equal to H2 minus H1, value of delta H is equal to U2 plus P2 V2 minus U1 minus P1 V1. Now we can take out the U2 and U1 in single bracket. So we will get delta H is equal to U2 minus U1 in single bracket, plus in other bracket we can write P2 V2 minus P1 V1. See, pressure is constant. So at constant pressure P is equal to P1 and also P is equal to P2. So at constant pressure P is equal to P1, which is equal to P2. So we can write P at place of P1, also we can write P at place of P2. So what we will get? We will get delta H is equal to U2 minus U1 plus another bracket PV2 minus PV1. We can take out P from the bracket. So we will get delta H is equal to U2 minus U1 plus another bracket plus P, and inside the bracket V2 minus V1. We can take P common from the two terms, and that's why we will get delta is equal to U2 minus V1 in first bracket plus P in other bracket. We have to write V2 minus V1. But what is V2 minus V1? V2 minus V1 is delta V. What is U2 minus U1? It is delta U. By putting this, you can write therefore delta H is equal to delta U plus P delta V. So what we are getting, delta H is equal to delta U plus delta V. Suppose this is equation number 4.22 as given on the slide. Then what to do? We have to show delta H is equal to QP. Then the remaining part is we have to take the help of isobaric process. Why? Because in isobaric process, pressure of the system is constant. And according to the isobaric process, QP is equal to delta U plus P delta V. QP is equal to delta U plus P delta V. When inside and outside pressures are same, when the pressure of gas is equal to external opposing pressure, or when P is equal to P external. That time QP is equal to delta U plus P delta V. See the previous part, you will understand. Suppose this is the equation number 4.23. Now see carefully for equation number 4.22 and 4.23. For both the equations, right hand side part is same. That is delta U plus delta V. When right hand side part is same, and automatically for both the equation, left hand side parts become equal. Therefore, by using 4.22 and 4.23, we can write delta H is equal to QP. Or in other words, heat absorbed by the system at constant pressure is equal to enthalpy change of the system. This is the short answer question for 2 marks. So what will be the question? Question will be show that enthalpy change of a system is equal to heat absorbed at constant pressure, or sometimes question may be only show that delta H is equal to QP. That time you have to write this answer. Okay, now we'll go to the next slide. See the heading, relationship between delta H and delta U for chemical reactions. When our system is chemical reaction, that time what is the relation between delta H and delta U? Here there are two possibilities. In fact, three possibilities. Now, consider the first possibility. Suppose the chemical reactions in which reactants and products are in solid state or liquid state. Suppose our system is a chemical reaction, and suppose reactants and products are either in solid states or in liquid states. When reactants and products are in solid or liquid state, that time change in volume, that delta V is very, very less, because solids and liquids are less compressible. Change in volume is very less, so it is neglected. And when there is change in volume is very, very less, value of delta V is zero, almost zero. Just now we have seen at constant pressure, the relation between delta H and delta U is delta H is equal to delta U plus P delta V. Delta H is equal to delta U plus P delta V. If the value of delta V is 0, what will happen? P delta V will become 0. And when P delta V is equal to 0, what we will get? Delta H is equal to delta U. So what is the conclusion? When system is a chemical reaction, and when reactants and products are either in solid or liquid states, that time change in volume delta V is almost 0. That's why according to equation delta H is equal to delta U plus P delta V, we are getting delta H is equal to delta U only. Why? Because P delta V becomes 0. Why? Because delta V is 0. Change in volume is almost 0. Now, we'll go to the next slide. Other possibility is that reactants and products are in gaseous state. Means suppose our system is gaseous reaction. Reactants and products are in the gaseous state. When reactants and products are in gaseous state, that time change in volume, that is delta V, is very large. It is considerable. We cannot neglect delta V or change in volume. If this is the case, then we have to see what is the relation between delta H and delta U. Okay, so already we have seen the relation between delta H and delta U at the constant pressure is delta H is equal to delta U plus P delta V. Delta V is equal to V2 minus V1. So put the value of delta V. And what we will get? Delta H is equal to delta U plus P in bracket V2 minus V1. Delta V, we can write V2 minus V1. Then solve the bracket, what we will get? Delta H is equal to delta U plus P V2 minus P V1. Here, P is the pressure of gas or gaseous system and it is constant. V1 is volume of initial state or reaction state for the gaseous reaction, and V2 is the volume of product state or gaseous product state. Now, at constant temperature and pressure, by using ideal gas equation, you can find the value of P1, PV1 and PV2. Why you have to take help of ideal gas equation? Because our reactants and products are in gaseous state, or our system is a gaseous chemical reaction. Gaseous chemical reaction. So by using the ideal gas equation at constant temperature and pressure, don't forget the conditions. Temperature and pressure should be constant. So at constant temperature and pressure, according to ideal gas equation, we can find the values of PV1 and PV2. What is the ideal gas equation? PV is equal to nRT. Now keep pressure and temperature constant. What will be the value of PV1? PV1 is equal to N1 RT. And the value of PV2 will be N2 RT. R is also constant, molar gas constant, where N1 is the number of moles of gaseous reactants. Gaseous reactants. What gases is important. And N2 is the number of moles of gaseous products. Now we can put these values of PV1 and PV2 in the equation number 4.25. Put these values, then we will see what happens. For that, we have to refer the slide number, next slide, or we have to go to the next slide. See here, when the value of PV1 is N1 RT and value of PV2 is N2 RT, that time what will be the equation between delta H and delta U? So delta H is equal to delta U plus PV2 minus PV1. So by putting the values of PV2 and PV1, we will get delta H is equal to delta U plus N2 RT. Because the value of PV2 is N2 RT minus N1 RT. N1 RT is the value of PV1. So next line, by taking RT common from the last two terms, we will write delta H, or we have to write delta H is equal to delta U plus in bracket N2 minus N1. The common part outside the bracket, that is RT. So delta H is equal to delta U plus in bracket N2 minus N1 and outside the bracket RT. But what is N2 minus N1? N2 minus N1 is delta N. N is what? Number of moles. Number of moles is also a state function. That's why N2 minus N1 is delta N. And along with delta N, subscript G also given, that G indicates number of moles in the gaseous state. G stands for gaseous state. So delta H is equal to delta U plus delta Ng. G for the gaseous state. Delta H is equal to delta U plus delta Ng into RT. So what is the complete equation? Delta H is equal to delta U plus delta Ng RT, and G is for the gaseous state. So how to find delta Ng? Delta Ng is equal to N2 minus N1, where N2 number of moles of gaseous products, and what is N1? Number of moles of gaseous reactants. So every time I'm telling you, word gases is important. It is not given on the slide or even in the textbook, but here N2 is the number of moles of gaseous products and N1 is the number of moles of gaseous reactants. And the gaseous state we have shown by using the subscript G. So what is the relation between delta H and delta U when the chemical reaction is gaseous chemical reaction, or when our system is gaseous chemical reaction? That time the relation is delta H is equal to delta U plus delta Ng into RT. See here, simple question. Sometimes you have to answer at what conditions delta H is equal to delta U. There are two conditions we have seen when reactants and products are in solid or liquid state. That time delta V is equal to 0. Therefore, according to equation, delta H is equal to delta U plus P delta V. Delta H is equal to delta U. See, once again, I'm telling you, refer this. Delta H is equal to delta U when delta V is 0. And delta V is 0 when reactants and products are in solid or liquid state. So one condition is that delta H is equal to delta U when delta V is 0 or when reactants and products are in the solid or liquid state. What is the other condition? The condition is when delta N is 0. That time delta H is equal to delta U. When delta N will be 0? Delta N will be 0 when N1 is equal to N2. That is when number of moles of gaseous reactants is equal to number of moles of gaseous products. In a gaseous chemical reaction, when number of moles of gaseous reactants is equal to number of moles of gaseous products, that time delta Ng becomes 0. And when delta Ng becomes 0, that time delta Ng RT is equal to 0, and automatically delta H becomes delta U, or we will get delta H is equal to delta U. Now we'll go for the next slide. See, there is one numerical problem given in the textbook, problem number 4.7. See what is given in the numerical problem. Delta H of the reaction 2C, C means carbon, 2C in solid state plus 3H2 in gaseous state, the react to give C2S6 in gaseous state, is minus 84.4 kilojoule at 25 degrees